B, Unit 2, Session 1 continued. A, hey Thomas, what does theta need to be so that when I take the sine of that angle, theta is an angle, 30 degrees, 40 degrees, 90 degrees, so that when I take the sine of that angle, it will give me 1/2. What does theta need to be so that when I take the sine of it, it will give me 1/2? How do I get that? I'm going to take my fingers. This is what the video you're about to see. I need a 1/2 for sine. That means when I bend these fingers, one of these fingers, the fingers below the one that I bend must equal the top number. The fingers below the one that I bend, see I just bent this finger? The fingers below that finger must equal the top number. To get my answer, the bottom number will always be a 2. So it's going to be a fraction. The bottom number will always be a 2. So you don't have to wonder, like, 2? Yeah, 2 is going to be there. It's just the top number you need to supply. And here's how I supply it. Hey, Thomas, what finger do I need to bend so that there's only one finger below it? My ring finger. When I bend my finger, the numbers below represent sine. The numbers above represent cosine. You're going to see a whole video with it in just a moment, 5 minutes. And so, in this case, when I bend this finger here, I only have a 1 below. 1, okay, it matches. So what's the answer, Thomas? The answer happens to be 30 degrees. He is thinking genius. If theta is 30, when I take the sine of 30 degrees, I will get 1/2. How does he know it? He just bent his finger. The second one, let me do the second one. Ooh, oh, hello, cosine. To get cosine, what does the theta, what does the degree need to be so that I will get a 2 trapped on top in a house? The rule is this. The finger that I bend, the number above it has to match the top number when it's cosine. Hey Thomas, how can I get a 2 on top? I fold this middle finger. When I fold the middle finger, I have 2 numbers on top. And they match. Thomas, what's the answer to that question though? Like, what's the answer? The answer is 45. How does he know that? The video is going to show you in just a moment.
And this would be at 0 degrees. This next angle then would be 30 degrees. The next one would be 45 degrees, 60 degrees, and then of course the 90 degrees, right? So when I'm talking about this trick and what you can do using your fingers, that's what I'm going to be referring to. That's where I'm getting it from. It's from the first quadrant of the unit circle. Let's take all these away. Okay. All right, now I've got my hand back. I'm just going to write on my fingers, and no, you cannot do this during class. I'm going to write 0 degrees, 30 degrees. This thing always gets stuck. 45 degrees. 60 degrees, and 90 degrees. You can always put radians to 0, pi over 6, pi over 4, pi over 3, and pi over 2. So what will help you to memorize the coordinates of the left and the right hand side? When I'm talking about the coordinates, I'm talking about that, your ordered pair. Whatever number that we get by putting down whatever finger of the degree that we're looking at, we're going to take our number of fingers and we're going to put that underneath the square root and divide it by 2, and that will give me my answer. So let's do an example really quick. So let's say I want to find the first coordinate for 30 degrees. So I would put this finger down. Put that finger down. And what does that give you on the left-hand side? Well, I have 3 fingers there. 3 fingers is what will go underneath here. So this answer is the square root of 3 over 2. And the right-hand side is going to be how many fingers I have over there, which is 1. So then I'm going to put the square root of 1 divided by 2. And of course, the square root of 1 is 1. So that really is just 1/2. Boom. That's the answer for 30 degrees.
Hey, Thomas, answer A for us, please. All right. I need 2 answers. Let me get one. Hey, what's the sine? What degree gets me the 1/2? Sine is always the bottom one, and I need a 1. Fold this guy. There's my 1. So far, I know that 30 degrees, 30 degrees, begins the process. It's not going to end the process because we have to put in radians, and we need a second answer. So 30 degrees is one of the answers. What's the other one? On the little chart that I gave you, I'm looking for every place where sine is always the second number in the coordinates, where sine is positive.
90.
Okay.
150.
I hear 90, I hear 150. Can I have someone break the tie? On the chart, I'm going to highlight in just a second.
1 is 330.
What is it that they're looking for? Like, I don't even know what I'm looking for. I'm looking for partners, coordinates, where sine is a positive 1/2.
150.
I hear 150 as the second one, and of course 30 I was able to supply with my hand. Here's what I want you to do on your chart with a highlighter. For A, go to your chart and highlight the 2 degrees where the sine, the second number in the coordinate pair, is a positive 1/2. They will all have 2 partners. In other words, this term is a negative radical 2 over 2. Now, if you just had a chart to just look it up on, you'd be good. But what's going to happen when you take your test? The first, more than half of it, you will not have the chart. So you have to get the first answer on your own. Well, what is he even talking about? Hey, Thomas, do B for us. Ignoring the negative, the first question I'm going to ask is, hey, with cosine, how can I get a 2 on top? All right, cosine, I need 2 fingers on top. Okay, there it is. If I bend this guy, I get 2 on top. So I know, well, I happen to know, that anybody know what degree the middle finger is?
45?
Yeah, it is 45, 30, 45, 60, 30, 45, 60, 30, 45, 60. It's 45 degrees, so I know, at least I'm going to write it down because it may not quite be the correct answer to begin with. 45 degrees is important for some reason. I just got to figure out how I'm going to do this thing. All right. 45 is important, but here I got this negative radical 2. So what I'm about to look for is who are the partners to 45 on that chart. So let me see if I can get my chart. This chart is from, I can't tell which, what's the very beginning of that paper that I took from you. If you look at this chart, some people may have figured it out, other people are like, you're talking, but I have no idea what you're talking about. I'm going to try and get to that picture so I can put it on the video so when you rewatch the video you can see. But until that time, can someone tell me which cosines have a negative radical 2 over 2 as their thing? Say it again.
35.
A 135. There must be another one.
215. Oh, 225.
225.
Yeah, 225.
Please look at your thing to see where they're getting that from and take a different highlighter color and highlight those degrees. If you can't see it on here, you're like, where are they getting these numbers from? And then I might even tell you how it relates to the 45. So let's do this. Let's pause this. On this chart here, notice that all of the special radicals are all the same numbers over and over. There's a 1/2. There's a 1/2, a 2 over 2, a 3 over 2. Ooh, how about that? How about 1, 2, 3? The blues are 1, 2, 3. The reds are 1, 2, 3 going backwards. They're looking at the top number. That's a pattern. Blues 1, 2, 3. Oh, sweet. Oh, 1, 2, 3. Oh, yeah. 1, 2, 3 in the red on the bottom. 1, 2, 3 in the. Oh, yeah. So there's a pattern. Oh, yeah. All right. The rule will be this. Let's do cosine first. Cosine are the first numbers. Cosine goes this direction or that direction. Notice here, this 3 over 2 is just like this 3 over 2. He happens to be in the positive section. He happens to be in the negative section. This radical 2 over 2, positive. negative. Hopefully you can feel it, just like XY table. The positive numbers on the right, the negative numbers on the left. So like having a 1 and a -1, 2 and a -2 from old school. Okay. Same thing on the bottom. Look at the blues on the bottom. Because the first coordinate are your cosines, it's always the same number, just positive or negative. Ooh, don't make it red. And don't make it blue, because I think that means something. Positive or negative. Just looking at your chart, the pattern on your chart, because you're going to need the chart to get your second number. All right, so here it comes. Positive U, same guy negative, because you're on opposite sides of the sign. Same thing here, negative, positive. Do they have it? Hopefully they do, positive, negative. Same thing with signs, same thing, signs like your Y's. Positive 1, -1, positive 2, -2. And so for the reds, hopefully you can see, if I need two red 1/2s that are positive, I just look for them. You're a red 1/2, that's positive, and you're a red one. No, where's your friend? Oh, there he is over there. So you're like filling in a puzzle. How about two red radical 2/2s that are negative? You're negative. Oh, because you're in the negative zone, and you are negative. So 1, you always give 2 answers. 2, where are you going to find them? On the chart. 3, the first answer you're probably going to supply with your fingers. The second one you're going to have to figure out on your own. So let's see. For the reds, positive, negative. This is for me right now. All right. For the reds, positive, negative. For the blues, positive, negative. Let me do one quick thing. Just for my own mind, blues are my X coordinates. Blues are my X's. Red, you're my Y's. Okay, got it in my head. Red is my Y-axis. Blues are my X's. Blue, left, right. All right, so now let's see if I can back up to the other thing and get one other easy answer, unless all the easy ones are gone. Back up, back up. Where do I find where I was? Over here. I'm going to skip tangent because we need to watch the lady on the tangent. Let's go to the next page where they do. Hopefully she does. And technically we're not finished on this one. Technically they want us to change these degrees into radians. But for now, let's just find it first, because changing a degree into radians is just doing a division problem. All right, what do I got there? Ooh, yeah. All right, so because it's so easy to bend your fingers, they made A a little tricky, and they made B too tricky. Like, dang, come on. Some kids aren't even like math. You're going to do that to them? But they did. All right, how do we do A? Step 1. Define X. We have to solve. We got to move everybody over so that all that we have left on one side is just sine X. Because they're multiplying 2 times sine, can someone tell me how we're going to get rid of the 2? Divide 2 on both sides. Which is going to leave us with sine X equals 1/2. That's step 1. Once you have sine X equals 1/2, and what you're doing, of course, you are finding the degree that gives you the answer. So instead of giving you the problem, 30 was the answer, they're actually going to give you the answer. You have to go backwards. Here we go. Anybody know what degree X needs to be to produce a 1/2?
90? No,
Try 90.
Oh wait, no, sorry, I didn't know you meant on that.
Yeah, the finger thing. 30 is correct. When you fold this hand here, this finger here, it leaves a 1 on the bottom. The bottom ones are the signs. So this 1 here is that same one at the top of that fraction. So we know for this one, the answer will start off as a 30. And there is a partner. There is another place where sine happens to be a positive 1/2. Now this is the one where you're going to look on that chart. Please look on the chart and tell me, where is sine also a positive 1/2? Oh, yeah. Is it this? Is it this? Oh, sorry. All right, 150 is it. The good news with these is if we did like 10 of these, there's one, where's the other guy? And there's his partner. take a look at it, pause, think about it, see how you're going to do with it. Because I'm not a hardcore math guy, I wouldn't offer this problem, but because some people are, and that's whoever made this test, I'm going to make it regular. Step one, we need to solve this equation for cosine x. Because we have this, well, someone tell me what you think the first thing we would do to this problem to try and get cosine x alone. It's like solving an equation.
You subtract it from you add it from the other side.
Right now I'm disappointed they did that too. Because you're right, normally you do an add because that's the plus sign in the middle, but since it's a negative number out front, you're actually going to wind up adding radical 2 over 2 to both sides. I'm going to do it, it's going to be ugly, but here's the beauty. It's going to end with cosine x equals some fraction, some famous fraction. 1/2, radical 2 over 2, or what's the third one? Radical 3 over 2. It has to produce one of those three famous fractions for it to match your little chart. So let me do some work. Sure, why not? Here we go. Plus radical 2 over 2 plus radical 2 over 2. Now I'm going to need some space over here to actually do the work. Sideways, up and down, sideways, up and down, sideways, up and down, sideways. I'll go sideways. Negative radical 2 plus that radical 2 over 2. I'm going to turn this into a fraction, get common denominators, and then add them. For people who don't like math, this should be like a nightmare for you. Enjoy the feelings. Here we go. Step 1. Put you over 1. Hey, someone who knows math. Hey, what's the common denominator between 1 and 2? Say it again, but loud?
2.
Yeah, 2. You always want the bottom to be that. So I'm going to multiply 2 on the bottom. Now, you will have to show this work on the assessment. There will be one quite similar to it. You will have this video to watch more than once. You can skip whatever movie you're going to see. 2 times, I shouldn't have put x's, but hopefully you're okay with it. 2 times that is going to be a radical 2. Maybe let me put the denominator the same so you see when we have common denominators. Over here, you're just going to still have that radical 2 over 2. The best part about this is just doing regular fractions. I just wish some important people walking by, watching you all, because they would think you're super smart when really this is like 7th, 6th, 7th, 8th grade when they start adding fractions with unlike denominators. Yeah, the top is radical, but whatever. The radical operates just like the letter x. In other words, negative 2 plus a positive 1. The radical 2 is just going to come along with it. You'll see what I mean in a second. See if I can write that down. It makes you look smart, but really, you're just doing old school work. So let's, on the top, radical 2 plus, I should put a 1 in front of the second radical 2. I'm not going to do it. And then the bottom, all over just a regular 2. Sidebar over here, just so someone who doesn't do math and radicals scare you when they follow a number. When they do, they really are just this problem here. Someone knows this one. Let's put them in green. Radical 2x plus x. Negative 2x plus x. Can someone tell me what negative 2x plus x equals?
Negative 1x.
Negative 1x. And unfortunately, we don't write the 1. Thanks, math.
Or yeah, negative x.
No, which is fine. This thing here is the same thing as all those radical 2's, where the x, the green x, does exactly the same thing as the radical 2's. Tristan? So here's the final answer over here. Then we see if you can make the connection. I'll even put it in green. Negative 1 radical 2. And you guys really should know. The only reason I would show you this is because they're going to require you to know it on a test. Because
Thomas,
yes.
how'd you get the negative 2?
Tick. This guy here or this guy here? This guy here.
There in the bottom. The blue? Yeah.
This negative 2 came from multiplying 2 times negative radical 2. I shouldn't have used an X, I probably should use a parenthesis.
Yeah, but so you don't times that 2 to the other.
Right. Outside with outside, inside with inside. If you are not one of the inside kids, you're not one of the cool kids, sorry dude, you can't be at my house. I'm going to be playing Nintendo inside, you can look through the window. You don't get to touch the window. Yeah, you're not like that. In any case, let's see if I can put what we just did all together so that you will literally be a smart person. Now my space is bad, but here's what we just found out. Cosine x equals all this junk that we just did. Box it. Sure, I'm going to box it right here. Box it. Yeah. Cosine x equals, oops, you're going to mess it up? Right. The only reason they did all of this, for those who don't know, is because the finger thing is way too easy. If we just gave you cosine x equals negative radical 2 over 2, let me put it in red so that it, if they just gave you radical cosine x is negative 2 over 2, here's all they'd be asking you. What finger do you bend so that you will get a 2 for cosine? I bend the middle finger, there are my 2 for cosine. Therefore, 45 degrees is important to begin with. And now I'm ready to look at my chart to find out, oh dang, if I have a chart, I don't even have to bend my fingers. There's no way I can give you the chart at the beginning. I'm going to make you do this bend the finger thing. But if I have a chart, this question here just means look at the chart, look at the first number in the ordered pair, and find where do you see a negative radical 2 over 2. Someone look on the chart and tell me where the 2 places are. Where the first coordinates again?
225.
And the partner? They always are, will be 2.
315.
2, 2, 5, 3, 1, 5. But I do want you to put down a 45. Now the 45 is for me to know that you know how to do the finger thing. If on your test for this one, you don't have a 45, I probably will not give you full credit. What do you mean 45? That is, the only way you get this 225 and 315 without a 45 is that you just look straight at the chart. The 45 tells me at least they know how to find the famous ones, which is usually the 45, the 30, and the 60. The other part that's true is 45 is a reference angle for these other 2 guys. In any case, let me pause. Let me mark it on the chart. So, where's my chart? What did I need? A negative radical 2 over 2. Where are you, radical 2 over 2? Boom. And boom. 225, 245. So for those who are like, I don't know where these answers are coming from, they're all coming from this little thing here. And it's so easy that if they just ask you the easy way, it'd be trivial. In other words, try this. Everybody look at your chart. Please find 0 as the sign. Please find 0 as a sign. What degree would you find 0 as a sign?
180.
I heard 180 and I heard 90.
And 180.
Yeah, right. So let's break the tie. I heard 3 answers so far. I heard 180, I heard 90, and I heard 0. 2 of them are correct.
Well, yeah, 180 and 0.
Yeah, 180 and 0. Because basically, let me ask it in English. Please find where the coordinate is 1 for the y. 1 for the y coordinate. 90 and
270.
and 270. Do you know what you're looking for? Uh-oh. What did I say? 1 for the y?
Yeah, for y.
90 wins. Y is at 270 win.
Oh, it's a negative 1.
Yeah.
Oh, I thought you meant just negative.
Right, yeah. But it would have to be. But at least you know where you're looking. You're looking at the red numbers. All right. Let's pause it. Answer in green. All right. The last thing we need to do is so that you can get tangent. Play the lady, play the lady, play the lady. Let me see what else. I'm going to rewrite this problem as a regular equation, so some of you who know how to solve regular equations, you'll know how to do it. If I'm solving for tan, this problem would look something like, x equals, so 3x, let's make you, no, something not quite about that. How am I making that? I'm gonna make you a y. Yeah, I'm gonna make you a y. 3y. And you're gonna solve for the y. As a matter of fact, I'm gonna have you solve for the y while I get cue up that video. After you solve this and look at the video, that'll be the last thing you do today. Let's make you a 1x. And let's make you a 2x. As if they have colors and it matters. Here is your task. Please solve for y. Get y alone. This ugly problem just means this. If you can do it with this, at least you know what you're going to be trying to do. It doesn't guarantee that you know how to add, subtract radicals. The radicals represent like a letter x, and everybody else is what you see. Do me a favor, solve for y right now. While you do that, hey Thomas, what would you do to get the x over? Why not even do it the Thomas way? First, I just take the x and put it on the other side. Leave me with this 3y equals a 2x minus x. When you move something over, it's the same number but the opposite sign. From there, I would divide. I mean, I guess I would do the word. Come on, come on. How did I lose you? How did I lose you? Come on, come on, come on. You? Sure, went on the next line. Let's make it all in blue. 3y equals 2x minus x, which is just a 1x. And then from there, I'm going to divide that x by a 3. What was y equals x over 3. That's not the answer, but that's how I would get mine. I could have subtracted the x from both sides. That's the traditional way to do it. Throw it over, divide by what's in front of the y. That's how you solve for y. Well, and I used up way too much space to do it. You're going to throw over the 3x, the radical 3, to the other side. You're going to subtract 2 away from it. In other words, instead of having an x, you're going to be left with just a radical 3. When you divide this 3, that's in front of tangent on the bottom, you're going to wind up with, ooh, let's see if I can make the connection so someone can see this. The y was that tangent x, they'll wind up with tan x. The x's were the radical 3's, ooh. And the regular 3 was just really a regular 3. Oh, no way, that was sweet delicious. I wonder if I'd have them do that on a test and then just resubstitute in the regular stuff. That way they don't have to actually work with radicals. They can just work with letters. Oh, that's a sweet idea. I like it. All right, here comes.